note it down. You just note it down that same shape are here, same shape are here, and size may vary, size may be different, and if we focus on their resemblance or their observing nature, we just say that corresponding angle must be same, their corresponding side must be in same ratio. Same ratio also means proportional. Okay, in next 15 minutes I will be telling all about these similarity. Okay, here you just observe, you know this, that equilateral triangles have equal angles. Whatever the equilateral triangle you consider, they have equal angle. You know what it is? Equilateral triangles have all angles equal. Do you know what it is? Tell me then. If you have equilateral triangle, I'm saying that all angles are equal. Now the condition is very simple. The condition is, in equilateral triangle we actually have all angles equal. Let's say they all are x, then as per angle sum property they must be equal to 180. Do you agree with this? And that means x must be 180. That means thrice x must be equal to 180. That means x should be equal to 60. And that is why they all are always 60. These angles are always 60. Not only with smaller, it is always okay with every equilateral triangle. Whether it has more dimension, higher dimension, that means whether it has smaller size or larger size, the angles are going to be same. It is quite obvious. They all have same angle. That means angle A is equal to angle P. Angle B is equal to angle Q is also valid here. And angle C is equal to angle R is also valid here. And that means first property is valid here. Understood? And about second property. Now if I take the ratio of AB with this PQ, we will get 2 over 4, which is only 1 over 2. Similarly, if I take the ratio of BC with QR, it is again 2 over 4, that is 1 over 2. And again if I take the ratio of AC with PR, I will be getting 2 over 4, that is simply 1 over 2. Here the second property is also valid. Their corresponding sides are also proportional. That means they are in the same ratio. And whenever you get such a condition, whenever you get such a scenario, you can just say that those two triangles are similar. And that is why equilateral triangles are always similar. And whenever they are similar, we use this symbol. Triangle ABC is similar to triangle PQR. This is the symbol we use whenever we get two figures to be similar. And not only equilateral, all kind of squares are always similar. All kind of circles are always similar. And for similarity, these are two rules that we focus. Are you okay up to this? Okay. Okay, very fine, very fine. Now, do we need to figure out all these angles equal every time, all these sides equal every time? The answer to this question is that we do not need to conclude about their all 6 dimensions every time. Why? Because we have some similarity criteria, and if we prove them following that similarity criteria, we can say them similar, we can call them similar. We need not find all those corresponding angles equal every time, all those corresponding sides proportional every time. Those criteria are SSS, SAS and AA or AAA. I'm going to explain these 3 criteria in much detail now. If you have these 2 triangles there with you, and you just prove that AB over PQ is equal to BC over QR is equal to AC over PR. If you just prove this, you can say that you have used SSS, and you can just conclude that triangle ABC is similar to that of triangle PQR. And now by CPCT you can say that they are corresponding. CPCT is corresponding part of congruent triangle. Here we use CPST, corresponding part of similar triangle. By CPST you can say that. Do you remember congruency? Yeah, in similar way it is similarity. By CPST we can say that P is equal to Q, B is equal to Q, C is equal to R. They can be just said equal by CPST if they are proven similar ones. You need not calculate all those 6 parameters, rather approach to these criteria. Now what happens in SAS? Now you need to work with only 2 sides. Like if I'm going to show that my AB over PQ here is equal to AC over PR here. If AB over PQ is equal to AC over PR, and this corresponding angle A and angle P are equal, you can prove that they are similar by SAS. And once they are similar, we can also conclude about other parameters. We can now conclude that BC and QR should also have same ratio, and angle B should also be equal to Q, C also equal to R. And in AA we just need to prove that they are having 2 angles equal. If I just say that angle B is equal to angle Q, angle C is equal to angle R, we can conclude about their similarity. Why do we not take third angle? Because if 2 angles are respectively equal, the third one is also going to be equal. That's why either you only go through AA, or AA is also AAA. If you just prove 3 corresponding angle equal, you name it AAA. If you are only going to prove 2 corresponding angle equal, you just name it AA. Are you okay with this criteria? In this way we prove those triangles similar. If similar, they are not given to be similar, then we use these criteria. Are you okay with this? Are you okay with this? Okay, fine. Now let's consider that question. The question is very interesting. I'm going to take it. I'm going to consider this question. Okay, the question is here in front of you and you want my help here. First of all, I will just tell, it is given here in the question that triangle ABC is similar to that of triangle ADE. It is actually given in the question itself. In this particular question, you are actually given with these 2 things. The first one is those 2 triangles are given to be similar. And if they are given to be similar, you need not use these SSS and SAS and AA or AAA, because they are already given to be similar. That means if they are similar, ultimately their corresponding angle A is equal with that of A, B is equal with that of D, C is equal with that of E. It is already known to us. Similarly, AB and AD is given to be having same ratio with BC, and DE is given to have same ratio with AC and AE. It is our ultimate conclusion if they are given to be similar. And here we are using these conclusions. We are going to use the second conclusion. Okay, what is our conclusion? The conclusion is AB over AD. Right now I am given with AD, and AD is given to be how much? Can you tell me the value of AD? It's 5 that I can see. Yeah, it's 7. Is it that? You just confirm it, because you have the question with you. It's 21. It's 4, and it's 16. It's bit blur, but we can just figure out it. Okay, now we are supposed to answer this EC. Let's say it is X. Now you use the concept here. Your AB means 7 plus 21 is over AD. AD is 7 over here. Okay, because ABC, I used AB over AD, then BC over DE, it is DE. Okay, BC is 16 over DE is 4. And also, the third one is, C, AC over AE. AC over AE. And one more thing is, DE is here. DE is here. And AC over AE is also here. Okay, AC means, can you tell me the value of AC that we used? AC means 5 plus x and AE means 5. Now you can take these two equal. Actually 28 over 7 is also 4 and 16 over 4 is also 4. You can equate this with 4 only. And finally you got 20 equal to 5 plus x. You subtract 5 both sides. You will be able to get your x, which is 15 centimeter. Please tell me whether you understood everything or not. Yeah. Okay, very good then. Let's proceed towards few more questions of the same kind. Okay, let's consider this question, but it's not properly visible to me. You need to tell me the dimensions if you have the original copy. It seemed to be 1.2. You just tell me the original dimension if you can. Do you have original copy? Okay, then no problem. It's 1.4 that I think. It's 1.3. Okay, all right, we are considering it. It's 5.2 that I think. It's 5.6 that I have, and it's coming out to be. It's not properly visible now, but 4.8 I just think of. These are two figures. We need to tell the scale. Okay, I'm telling very interesting factor now. Whenever there occur dilation, you know the meaning of dilation. You all guys try to understand the meaning of dilation. Actually, in English, dilation means to enlarge something. Dilation means enlarge something. Dilation is enlarging something. And if you are enlarging something, the angle you will not change, and that's why by AAA criteria you will be able to prove them similar. Dilation is enlarging something, and it results into two similar figures. That's why we deal dilation under similarity. We deal dilation under similar figures, because dilation only enlarge an object. Dilation is enlarging something and it results into two similar figures. Here we get two similar figures. It's very important thing. And those similar figures, you understand here, the present figure or the original figure or the initial figure, whatever you take initially, whatever you take originally, is said to be your object. And the drawing that you draw, like if you want to draw the length of or distance of India from USA, you can't draw on paper originally. That's why you have to draw it by considering the scaling, and such a scaling comes under, you can just say that it is a drawing of an object. Here drawing is going to be there. Okay, if we consider this object and drawing, and if we take the ratio of drawing with that of object, you call it the dilation factor, or simply the scale factor, or SF. SF is equal to length of drawing over length of object. It's also have another name, representative factor, but we generally use SF here. Okay, now if you are supposed to tell me scale factor of this, you can usually tell it, figure Y was dilated. This was dilated figure. That means it is your drawing. and figure x is your original figure, that means it is your object. And as per the formula, what you do here is, you take the length of drawing first. That means you will take drawing first, 1.2 over 4.8 here. Again, you can either take 1.3 with 5.2, or you can take 1.4 with 5.6. They all should give you the same result, because dilation never give you not similar figure. It always give you similar figure. That's why this must have same SF for all sides. All sides should be scaled with same proportion. Here you will get 12 times 4, 1 over 4. Here you will get 1 over 4. Here you will get 1 over 4. Now here this is reducing dilation. Okay, very good. Let's try to understand this then. Okay. Here, if you have a scale factor, actually in dilation we consider enlarging scale factor where scale factor is greater than 1. Sometimes if scale factor is exactly 1, you call it equal size scale, and if scale factor is less than 1, you call it reducing scale. Generally, if you want to plot something in math, you use reducing scale. If you plot something by, like if you are observing a particular microorganism, you in that case enlarge something. Here the scale is reducing size, but it comes under dilation. Dilated figure is Y. Okay, figure Y was actually dilated to create figure X. Figure, okay, 1 minute. Figure Y was, oh, 1 minute. Okay, alright, I have not read it clearly, that's why it happened. Here you need to understand, the dilated figure is not this. The dilated figure is actually second one. That's what I'm thinking, that why it is coming out to be less than 1. See, figure Y was dilated to create figure X. That means it is your object. It is your original figure. Now you are getting drawing. Okay, length of drawing is actually 4.8 over 1.2 or 5.2 over 1.3 or 5.6 over you can write how much? 1.4. It's coming out to be 4. 4 in each case, obviously. 4 is your scale factor here. But if Y is drawing and X is object, obviously it is 1 by 4. But if you clearly read it, it is very clear from this one that Y was dilated to create X. Y is not the dilated figure, but it was dilated to create X. That means Y is your original figure, which should be object. Here scale factor is 4, not 1 by 4. Please rectify this. Got it or not? Okay, very good. Okay, now let's consider few more questions. Okay, alright, now let's solve the next one. It's also whenever there is dilation or whenever there is reducing size of any object, if you are reducing the size of any object, you will always get similar figure. This is the very important point you need to understand. Okay, now here this is 10 to be given, this is given to be 15. If you observe carefully, it is given to be how much? No, it's a bit blurry, you can tell me the exact value. Okay, no problem. Here wx, if wx is 5.4, it is given. You need to tell me the length of AB. It's the question. And as I think this should be 10 over what is given in the question is very interesting. They must be, if they are dilated, they must be similar. Do remember that. Wx by z was dilated to form ABCD. Which was dilated? It was dilated, that means it is object. And the obtained figure is here, it is drawing. Okay, that means as per, if we want a scale factor, we need to take your this value first. Which value first? Drawing first, isn't it? Yeah. And what is the drawing that you have? Drawing over here is ABCD. That means object is going to be WX. Drawing is going to be corresponding to WX. We have AB here. AB. Similarly, you can have XY with XY here. Then here should be BC. And similarly, we can have other values as well. No issue. We need not to use BC rather, because we already know that they are dilated. If you even know this dimension, or even if it is not clear, we can find out the answer, because we will directly use WX, that is 5.4. We want AB, let's say it is X. We will write XY, which is given to be 15. We will write BC, and even we need not use, do we need BC to, yeah, BC need to be used. And YZ is equivalent to that of, okay, CD. If you don't want to use BC, no issue, you use YZ over CD. And YZ is here 15, and YZ is 15, and okay, WX is 5.4, AB is X, and then XY is 5, but we are not, we are using these two. Then YZ is 15, and CD is how much? CD is 10. Okay, we can directly multiply 5.4 with 10 and 15 with X, and further we will divide this 15. It's coming out to be 54 over 15, and further you can cancel it with 3, and it's coming out to be 5 3s are 15, 5 6 30. 33.6 units is going to be your answer. Are you fine with this? Okay. Similarly, we have other question, like here if we are given with AD, can you answer WZ? I want you to answer it, because here you can just say that WX is equal, WX over AB equal to XY over BC and YZ over CD, and one more thing, WZ should be equal to this AD, because the similar figure has corresponding sides being proportional. That's why we are saying so. And a scale factor is the same thing. The ratio of those similar sides, ratio of those corresponding sides is actually known as similar SF, that is scale factor. And a scale factor, in a scale factor, the first ratio that we take is of drawing. Yeah, should we conclude the session? And here what you did is quadrilateral WXYZ was dilated. Okay, dilated figure is small. That's why scale factor should be less. I should write AB first. I'm using 1 over SF here. Don't worry. That can be the same sense. Okay. Taking drawing first or object first doesn't change the thing, but when you want to find out SF, you must take drawing in numerator and object in denominator. Okay, fine. I'm concluding the session for today. You take this question B as your homework. Find a scale factor. We actually determine the scale factor. Can you tell me what is the scale factor? The scale factor can be obtained. Length of drawing is 10 actually. Length of object is 15 we need to take. That's why the scale factor is less than 1, which is 0.67. That means length of image has been reduced with this scaling. Okay. Here the dilated figure is, okay, here we are dilating, means we are dilating to reduce it. WXYZ was dilated to form ABCD. Here the dilated figure is the reduced size figure. Okay, fine. You just go through this question, determine the value of WZ using the same approach. It's your homework, and consider other if you want to consider. Okay, all right.